This is section 3.4. We're learning how to communicate with algebra. So we're learning a bunch of different definitions you may or may not have seen for the first time. The first one we're going to learn about is the word term. It's an expression formed by the product of numbers and or variables. Okay, so if you look at this term here, 4x squared, we consider that to be altogether a term. Okay, 4x squared, that's considered one term. Okay, we can also consider plus x is just a term on its own, and even just the number 6 would be considered a term. Okay, so this would be three separate terms, 4x squared, x, and 6. So terms in an expression or an equation are separated either by plus or negative signs, okay, but not division. So if we had something like 3x divided by 2, this whole thing would be considered one term. Okay, same thing goes for 3abx squared, y. Let's say there's 4 variables. All of this is considered one term. Okay, it's not until we do a plus or a negative sign do we consider it to be a separate term. Is there any questions about that? Okay, so we can see in the term then that there's two parts. There's what we call the coefficient, okay, and the coefficient is always a number, and it's a number, it usually always precedes the variable, okay? So, and then the variable is of course the letter. So there's two parts to a term, a coefficient and a variable. If we don't see a number, so something like x squared, who can tell me what the coefficient of x squared would be? Yeah, Henry?
1.
Yeah, it's 1. So if we don't see it there, it's actually the number 1. We just don't write it. Okay, just like we don't write an exponent of 1, we don't write coefficients of 1. Okay, so it is there, you just don't write it out. Okay, coefficient again is the number in front of the variable. All right, so if we look at this table here, we can see we're given various equations or expressions. The expression is here in the first column, and then we're just looking at what is the coefficient and what's the variable. So the expression 7x, our coefficient is 7, the term that the number before the variable, and the variable of course is x. Negative 4.9t squared, the negative sign goes with the constant 4.9, so it would be negative 4.9 is our coefficient and t squared is our variable. Okay, we take equations written from word problems and we create these expressions. So the first one says Jim earns $7 per hour as his part-time job. If he works for X hours, his earnings in dollars are 7X. So we have to be able to take a sentence like that and realize if we multiply 7 times his number of hours, we'll get his earnings. Okay. Similarly, here's the depth in meters of a falling stone in a wall after t seconds is given by this. Okay, so we get these formulas from word problems. The area of a triangle we know is 1/2 base times height. 1/2 is our coefficient. BH are our two variables. Okay. The area of a square with side length k squared. Our coefficient again we don't see it there, but it's a 1, and our variable is k squared. Amir walks 6 blocks to school. Our expression is just 6. It's just a constant number. So our coefficient is 6. We don't have a variable in this case. Okay, there's nothing that is being multiplied by. So there's our breakdown of a term, or our expression. We have a coefficient and a variable. A polynomial now is classified by the number of terms it has. So a polynomial can have, 1 to hundreds of different terms. When it has one term, we call it a monomial. So you can see there's 4 of them here. They're separating them by commas. It's a little bit difficult to see, but you can actually see that there's a comma here. So a monomial, example of a monomial would just be x, okay, or 3y, or negative 4a squared, or 5. Okay, these are all separate examples of a monomial. So a monomial is an expression or a polynomial with one term. Okay, so if we go back to these examples here, this would be a monomial. There's only one term. This is a monomial. This here would be called a trinomial. because there's 3 terms. 1, 2, 3. And a binomial would be 2 terms. So this is now a binomial, 2 terms. And this is also a binomial, 2 terms. Yeah.
So, sir, how is a monomial different from a term?
A monomial, it's not really different from a term. You're right. It's just one term in a monomial. It's just a monomial is used to describe a specific type of polynomial. Okay, so a polynomial being kind of different equations with different numbers of terms. A monomial, you're right, it just has one term.
And so a polynomial is basically a group of terms?
Yes.
Oh, okay.
That's exactly right. A binomial has 2 terms, and a trinomial has 3 terms. Yeah, so this is a good question. What is the difference between a monomial and a term? There's not much, right? A monomial contains one term. Okay? So if we look at example 2 here, it says classify each polynomial by the number of terms it has. So the first one, what are we going to call that, Tim? 2a. You want to call it a binomial, trinomial, or monomial?
Binomial.
Right, binomial because it has how many terms?
2.
Good. Justin, this one, B?
Monomial.
Excellent, because one term. Nicholas, C?
It's a trinomial.
Trinomial, excellent. And Adam, last one?
A 4-term polynomial.
Good, excellent. You see it down here, 4-term polynomial. This one you could also just classify as a polynomial. Okay, they're all polynomials, with the exception of B was a monomial, but a type of polynomial has more terms. Okay? So 1 or more terms. So if he said 4th term polynomial, it could have just said polynomial. All right, next definition we're going to learn. So we learned what a polynomial is. We learned what a term is. Now we're going to learn degree of a term. Okay, so the degree of a term is defined as the sum of the exponents on the variables in a term. Okay, so we know these are all terms. The sum of exponents. So, Joseph, what would be the degree of this term? X squared. What would be the degree?
2.
Good, yeah, the degree, because there's only one exponent here, so the sum of that exponent would be 2. Robert, the degree of this term?
Sure.
3b. Right, 4. It's the sum of the exponents. There's only one exponent. It's 4. Okay, Robert, C?
1.
Right, 1. Good. D?
3.
Good, 3. So 2 plus the 1 that we don't see. Okay. Tyler, the degree of E?
2.
2, good, because x is the exponent of 1, y to the exponent of 1, so you sum those two, you get 2. And finally, F, Luca in the front on the right?
1.
No. So remember, a degree is the sum of the exponents on the variables. Notice with F, Luca, there's no variable. So it would be 0. Yeah, there's no degree there, okay? You have to have a letter or a variable in order to have a degree. Okay? So we've looked at degree of a term. Now we're going to look at degree of a polynomial. So it's the exact same thing. The only difference is that in a polynomial, as we know, we can have more than one term. So we're going to decide the term of the polynomial based on the term with the highest degree. Okay? So we're going to look at all of the terms in the polynomial. The one with the highest degree is the one that's going to determine the overall degree of the polynomial. Okay? Make sense? Christian, what is the degree of this polynomial?
2.
No. So what's the degree of this term, x?
1.
Right? And what is the degree of this term, 3?
0.
Right. So which term has the higher degree?
I'll match.
And what is that degree?
1.
1. So the degree of the polynomial is?
1.
Good. 1. Okay, let's do the next one. So this term has a degree of what?
1. I mean 2.
And this one has a degree of?
1.
Okay. So what has the highest degree?
5x squared.
Right. And what is the degree of the polynomial?
2.
2. Excellent. Okay. The third one, Alvin.
3y minus 3.
Right, so what's the degree of the whole polynomial?
It is 3.
3, good. So typically the way polynomials are arranged, they always put the term with the highest degree first, and you've seen that so far. Okay, now finally, Kyle in the back, D. What's the degree of the polynomial?
X minus 6y.
Okay, what is the degree then?
Oh, 7.
Good, 7. So D is the only one where you actually see the degree came from the second term, right? Not the first term. You guys notice that? But it's still the highest term. 6 plus 1 is 7. 2 and 4 are only 6. So the degree of this polynomial is actually 7. Okay, we see that down here in the table. Okay? Any questions about that? Polynomial, term, variable, coefficient, degree, degree of term, degree of polynomial. Any questions? In the back. Yeah.
What happens when the degree of a polynomial, they're both equal?
Then it's whatever that number is. It'll still be the highest one, right? So if it's like x cubed plus 5x squared times y, they're both 3, so the degree is 3. Okay? Yeah.
Does a polynomial have to have 2 or more terms, or would a single one term just be called a term?
Yeah, I think you're right. I think a single term polynomial would just be called a monomial, and then 2 or more is polynomial, because poly actually means multiple, right? It comes from the word polymer, which is like plastic, plastic is made up of carbon-hydrogen chains. It's a repeated carbon-hydrogen chain, CH, 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 and that's how you get different plastics. Okay, that's where the word poly comes from. All right, any other questions about all of those definitions that we've learned? So if I said, AJ, what is a term?
It's a phrase of, like, it's an algebraic expression and it's in between the pluses and minuses.
Good. Okay, that's one way. Anyone else can describe it? One way you might describe it is you could say a term is made up of a coefficient and a variable, or just a variable, or just a coefficient, right? There's 2 parts to it, but it can have one of those 2 parts. And you're right, it's separated either by a plus or minus. Okay, but you can have many different variables multiplied and still be considered one term. All right, last question here. It says Cheryl works part-time as a ski instructor. She earns $125 for the season plus $20 for each children's lesson and $30 for each adult lesson that she gives. Write an expression that describes Cheryl's total earnings for the season. Identify the variables and the coefficients of each term. So we're going to take the value of $20 that she earns, times it by the number C, or the letter C, which represents the number of child lessons she gave, plus 30 because she gets $30 for the adult lessons times A, where A represents the number of adult lessons she gave, plus she always gets for the season $125. Okay? That's how they develop this equation right here. 20C plus 30A plus 125. Okay? And then so those are our 3 terms, 20C, 30A, and 125. Our variables, we just went over what they represented. C is the children's lesson, A is the adult lessons. And finally, 20 represents the earnings per child and 30 represents the earnings per adult. And 125 is the fixed rate she makes. One winter, she gave 8 children's lessons and 6 adult lessons. What were her total earnings? You're going to substitute in 8 for the children's lessons and 6 for the adults' lessons and solve. Very, very simple question. Okay, so we get a total of 465. So our key concepts. Algebraic expressions can be used to communicate mathematical ideas. Okay, we're starting to see that. A term is the product of a coefficient and a variable part. Okay, careful there. It can also be, a term can also be just the coefficient, right? Doesn't have to be a number times a variable. Term can be considered just the number 6, for instance. A polynomial can be a single term or a combination of terms using addition or subtraction operators. Okay, so that's where we talked about terms need to be separated by either addition or subtraction. Finally, a polynomial can be classified by the number of terms it has, monomial, 1, binomial 2, trinomial 3, by the number of terms it has, or by its degree. A degree, again, being the sum of the exponents. Okay, and a degree of a term is the sum of the exponents. A degree of a polynomial is the sum of the exponents of the largest term. Okay, the term that has the largest degree, that is your polynomial degree. Got it? Any questions? All right.